Japan. The Japanese engineering edge. So we are very pleased to have with us Mr. Kiran N. Deshpande, who is the country manager of India in Technology Initiative from Altek Europe, UK. To speak about his credentials and his background, Mr. Deshpande is a chemical engineer from LIT Nagpur, and he's also holding an MBA in finance from NMIMS Mumbai. He has extensive experience in petrochemicals, process industries, and aluminium sector, and has worked with reputed organizations, including Godrej Unilever, Pyrotech, Morgan Advanced Materials UK, and RIA and RIA Casthouse Engineering GmbH. And he is a very valued member of the IBAAS Technical Committee. So I am very fortunate to having him many times, meeting him when I was in Nalco. At the same time, we have met also in IBAAS, and I respect his technical acumen very highly. So I believe, and I am very sure that today's lecture will be one of the path-breaking lectures we have heard in this series. And now I request Mr. Deshpande to start the presentation.
Pradeep, thank you very much. Good afternoon to everyone, and a special thanks to two of my friends from Japan, Mr. Mr. Toru Teratani and Mr. Avadut Desai. So they are in Japan, and I recommended them to participate. They would have been more happy if we would have been having more participants, but due to certain reasons, we have limited participants today. But anyway, this is going to be a recorded session, so people who are not able to join today will be able to see this presentation later on. So in my more than 30 years of experience, one of the thing is on the shop floors of different process industries, including petrochemicals, complex chemical process, and aluminium. I would say the safety has been the topmost priority everywhere. In petrochemical, it is beyond imagination, because safety comes first, then the production. In aluminium industry, it is not the story at all. Sometimes the safety has been put on the back burner, and the production is given a priority. In case of safety, there are various ways and means, technologies, methods, practices, human approaches to achieve the safe working conditions of human operators on the shop floor, and the protection of the equipments and the protection of the premises. So in this whole scenario, sometimes the solutions are quite unique, and they are quite robust and simplified. And this is where I would be more interested to speak about HardLock Japan. This is a company which has developed a very robust, most simple but most effective technology in the world, which is called as a locking nut. And the presentation is about the locking nuts. So locking nuts are used in place of any other nut to hold the bolt. Now the bolt and the nut assembly is basically to join two surfaces. And when there are two different surfaces, they are likely to be under various stress and various vibrations. And these vibrations most of the time creates a loosening effect. And sometimes the loosening effect is very fatal and destructive. To overcome this, there are ways and means of protecting the locking of the bolt and holding the surface together. So there are double nuts, washers, locking washers, plus and any other methods. But in the world, the best method is developed by the company in Japan called HardLock. And I'm going to show the presentation. So I am presenting my presentation over here. I hope my screen will be visible. Is it visible now? Hello?
Yes, sir.
Yes, it is visible now. Yes, it is visible.
Visible, yes.
So HardLock nut is a very unique technology. It is patented and it is developed in Japan, and they are offering to the industry is safety is the power. So safety is power. So with this first slide, I would like to run through a very small video. And this video will tell you everything about HardLock. And then we can go run through various applications.
Allow me to introduce you to the HardLock nut. Our powerful, original, self-locking nut keeps any application it is adopted in safe and secure all over the world. One of the world's fastest and the safest high-speed trains, the Japanese bullet train Shinkansen, is supported by the powerful self-locking effect of the HardLock nut. The train and railway tracks are exposed to vibration and impact beyond imagination. The HardLock nut is the only self-locking nut which can withstand such severe vibration and impact. Now, let us see how the HardLock nut compares to other nuts in vibration tests. This test equipment generates extremely tough vibrations and impact in accordance with National Aerospace Standards NAS 3350 and 3354. The nuts are marked prior to testing. By looking at the markings, you can see that the condition of the HardLock nut remains unchanged. These are the results of the vibration test. The single nut flew off after 12 seconds, and the double nuts after 30. But the HardLock nut did not loosen at all, even after the maximum 30,000 test cycles and 17 minutes of vibration exposure. This is a transverse Juncker machine. It couples a bolt to a fixed plate and glider plate and moves the vibration plate transverse to the bolt shaft and measures any change in the clamp load. Here are the test results. The vertical axis represents the load applied in the axial direction of the bolt. In short, any loosening of the nuts shows up as a decrease in the clamp load. As the vibration frequency increased, the other nuts loosened and subsequently the clamp load dropped to almost zero. However, there is hardly any change in the HardLock nut's clamp load, indicating that the HardLock nut did not loosen. These severe tests have proven that the HardLock nut can withstand vibrations and impacts not only in the axial direction, but also from the direction perpendicular to the axis. The latter direction is considered to be the predominant cause for loosening bolted joints. The HardLock nut works by utilizing the wedge effect. Wedges are used in places like the torii arches of a Shinto shrine to firmly hold two pieces together. Hammering a wedge between the nut and bolt completely fastens the two. But this is hardly practical when you consider workability. So we divided the nut in two, whereby the convex nut acts as the wedge and the concave nut functions as the hammer. The convex nut is fabricated as a wedge by an eccentric structure that is slightly off-center. This wedge screws in between the concave nut and the bolt to produce a powerful anti-loosening effect. In other words, the convex nut acts like a wedge because it is off-center, and the concave nut functions like a hammer as it is screwed in. The HardLock nut began garnering worldwide attention when a research paper was submitted to a gathering of the American Society of Mechanical Engineers held in Denver, Colorado in July 2005. The paper scientifically proved that the HardLock nut never loosens because of its structure. When a strong impact is applied to a bolt shaft in the longitudinal direction, an ordinary bolt slowly turns in reverse. This shows the nut loosening under vibrations. With the HardLock nut, though some movement to the left and right occurs, you can see that the nut does not turn in reverse. This is the secret behind the world's highest anti-loosening performance that keeps the nut from loosening under any kind of impact. The HardLock nut is often adopted in applications where loosening will cause a potential risk to both people and application. Therefore, we are particularly committed to quality control and frequently perform various quality inspections. This machine measures the dimensions of a nut in 6 places at the same time. This is a nut fastening tester, and this is a high-definition digital projector. Besides this equipment, a variety of inspections are repeated to ensure durability, workability, and fastening and removal. Once the HardLock nut has been installed, it will not run loose, so performing frequent maintenance work is not necessary. Therefore, costs related to maintenance can be reduced immensely by utilizing the HardLock nut. Let's take a look where the HardLock nut is utilized. First, the railway industry. The primary requirement of nuts used with railroads is that they never loosen. Loose nuts can lead to serious accidents. In Japan, the HardLock nut is used at stations and inside walls and other locations of the famed Shinkansen and many other lines to ensure safety. In the UK, the HardLock nut has been officially adopted by Network Rail since 2003, replacing a majority of the fasteners for trains, tracks, switches and overhead wires, and at stations. The HardLock nut has been adopted in the Taiwan High-Speed Rail. It was also officially approved by Queensland Railways of Australia and has been utilized in many locations. Japan is a country with many earthquakes. If a bolted joint were to loosen, the consequences could be catastrophic. The HardLock nut is adopted in a wide variety of applications, both domestically and internationally, including highways and bridges, skyscrapers, huge facilities, power plants, steelworks, and earthquake-resistant homes. Recently, the HardLock nut has been adopted by Vale SA in Brazil, the world's largest producer and seller of iron ore, in various heavy machinery and equipment, and has received an extraordinary evaluation for its remarkable loosening prevention performance, contributing to improvement in safety and extensive reduction in maintenance costs. And finally, let me introduce you to the HardLock family. This is the HardLock rim. It has a stopper for tooling on the concave nut to improve workability. This is the HardLock bearing nut. It is used in a wide range of industrial machinery to lock bearings and prevent loosening. This is the HardLock set screw, which revolutionized mold clamping in the automotive industry. HardLock industry always works towards improvement when developing new products. What started in Japan has spread around the world. The products of HardLock industry are fast at work in places you do not see within the foundations of society. Since our founding, everyone at HardLock industry, no matter what process they are involved with, has been forever passionate about safety in order to ensure world-class quality, making products that are guaranteed safe in any environment. Safety is power. Safety is HardLock.
So I have got the help from Mr. Avadut for preparing these slides. So this slide speaks about Mr. Wakabayashi. So driven by the desire to create a truly reliable locking solutions, Mr. Wakabayashi founded HardLock industry over 50 years ago after identifying flaws in existing locking designs. This concept was inspired by the traditional Japanese torii a symbolic structure seen at Japanese shrines. So as it is explained in the video, it has a the nut is divided into two parts: the convex and the concave. And the convex nut is having an eccentric protrusion and the concentric recess in the concave parts. So when you are tightening both these nuts together, the concave part acts like a hammer, and it's like a wedging technology. So the eccentric protrusion acts like a wedge. So this creates a very high level of friction is generated, and this creates a very high level of locking power, which is very unique in the world. And that is why this is very much mandatorily used in bullet trains. Even in India, it is used in bullet trains, and it is used in very high level of safety applications, even in aircrafts and defense. So this is some of the explanation on this slide. So if the bolt is not tightened with enough axial force, most of the external load acts directly on the bolt. This increases the stress on the bolt and raises the chance of breakage and loosening. When the bolt is tightened with the correct axial force, the external load is shared by all the connected parts. As a result, less stress is placed on the bolt, making it less likely to break. So proper bolt tightening is essential to prevent a bolt failure. In aluminum industry, if you look at the value chain, it has bauxites, alumina refinery, pot rooms, which is smelters. They are quite huge. Different cast houses, each cast house is having a high level of aluminum melting process, big furnaces, packing lines, warehouses. End of the value chains are aluminum foundries, which are highly involved in auto components and various end of the value chain products. So there are a lot of furnaces and robotics, assembly lines. So it's complex value chain right from bauxite up to end. So in every stage of the process, the safety is prime importance, and safety comes where there is a issue of loosening. So HardLock nut is one of the ultimate solution. In India, there are good companies like Maruti Suzuki, Tata Steel, Jindal. They have adopted HardLock nut in many of their applications. So in aluminum value stream, some of the equipments everywhere we find are blowers, gearboxes, overhead cranes, heavy vehicles, molten metal transfer vehicles. So they carry molten aluminum to the extent of 14 to 15 tons. Conveyors, vibro screen, robotic arms, pumps assembly. The list is unending. So Mr. Avadut Desai had given me some of the application in different industries. So in food and beverage applications, it is used in this particular application. He has shown M24 HardLock nut is used on the cone wall of an IBC tank handling powders and granules, ensuring secure fastening and preventing loosening during operations. So this is one application. In wine production tanks, HardLock nuts are used in multiple areas such as handrails, internal filters, conveyor systems to ensure fastening where welding is not possible and to prevent loosening caused by vibration and continuous operation. So why HardLock nuts? Because the tank wall is so thin for welding, so bolted fastening is required. HardLock ensures the joint remains secured without loosening. In the mining industries, mining is one of the most hazardous industries involving heavy machinery, extreme environments, and constant operational risk. Without proper safety measures, even a small failure can lead to serious accidents and operational disruption. HardLock nuts had demonstrated reliable anti-loosening performance under severe vibrations and heavy load conditions in mining applications. So these are some of the photographs where you can imagine these HardLock nuts preventing the loosening of the surfaces. So this is a tunnel boring machine, which is heavy load. You can see the HardLock nut applications. And there is no alternative to HardLock actually. Oil and gas plant solutions. So regeneration, gas heater pipe, header connections, flanges, where these HardLock nuts are used extensively in Ras Laffan, Qatar. Ras Laffan Liquefied Natural Gas Company. So these are oil refining complex in Tatarstan. So they are flange connections where it is susceptible to vibrations and corrosions. I had worked in such type of plants, and there is a concept called back hammering. So whenever there is a back hammering, the pressure comes in a reverse direction and it vibrates entire pipelines. So if there is a flange with an ordinary nut, it will go away, and then the entire material in the pipeline, in the very costly material, can go as a waste. To prevent this, HardLock nuts is a most remarkably adaptable solution, and it is most reliable. There is no comparison to HardLock nut. Rail tracks and train car application. This is the most important. I always love this particular application where you can find the advantage of HardLock solutions. The applications are exposed to strong external load in addition to severe vibrations. Switching from welding to improve workability of maintenance. Difficult to retighten or inspect the bolted joints once they are installed. Strict safety is required. Joints are not or very small, preloaded, and necessary to retrofit to existing worn bolts. So in the UK, when the accident happened, they immediately decided to go the HardLock. So these are some of the photographs. So the mandate was the Network Rail and London mandated a switch to high security HardLock nuts. And the results are over 500,000 installations across the UK rail network with 0% failure. Now these locking nuts are all maintenance free. So you can unlock and again you put it into the locking position. So you never have to go again and again and see the tightening, because once you lock the nut, it will remain as it is. So this is improvement with underfloor equipment mounting. So HardLock nuts have replaced welding to fix underfloor equipment of Shinkansen since 1992. So this is the benchmark of the railway industry, bullet trains. And so HardLock nuts is mandatory in the bullet trains. So this presentation today is that this particular concept can be taken to aluminum industry. That's why currently through my friends in India, we are explaining this concept to Hindalco, and they are likely to adopt HardLock nuts at various applications. So these are some of the photographs which are very impressive. The British Rail 395 series, so dual voltage electric multiple unit. Manufacturer is Hitachi. Maximum speed is 140 miles per hour. Operator is Southeastern. Number of builds 29, and car per set are 6. So these photographs show about the various applications of HardLock nut providing safety, and many of the applications all over the world have realized that this is going to be that ultimate solution. So the HardLock, the proven locking nut for steel mill applications. So where you can find the advantage of HardLock solutions, the applications are exposed to strong external load as well as severe vibrations. Switching from welding to improve workability of maintenance. Difficult to retighten or inspect the bolted joints once they are installed. Strict safety is required. Joints are not or very small, preloaded, and necessary to retrofit to existing worn bolts. So these are the various applications of the steel in the steel industry, coking and sintering plant. So it is fender, unloader, bucket, rail track, stackers, hopper lines, chain conveyors, coking plants, backstay bolt, guide car, insulation shield, sintering plants, hopper liners, conveyor skirts, moving gate, sprocket wheels, pallet cars. So everywhere so these are similar applications in aluminum industry where you can think of replacing your ordinary locking nuts to hard lock nuts, because in the world, all these comparative studies have confirmed that this is the only ultimate solution. Iron making, steel making, so blast furnaces, stove gas cutoff equipment, stove wall flange bolts, tire branch heat resist bolt blowers, molten iron transport, fish plate bolts, and rail track turnbuckles. So these are various applications. Fish plates and blowers are very common phenomena. In aluminum industry, we also have the rail connections for transferring alumina from refining to the smelter position, as well as blowers everywhere in furnaces, in pot rooms, and these are likely to get loose and create problems. To prevent this loosening effect, hard lock nut is one of the ultimate solution. So these are roll lifters, hydraulic tanks, feed roller. These are hard lock bearing nuts to lock the bearings. Hard lock nuts used in aluminum industry. So heavy machinery and constant vibrations are high risk operating environments, high temperature process and thermal cycling complex operation across melting, refining and castings. So hidden risk is fasteners loosening. So bolted joints are critical but vulnerable connection points. Vibration leads to loss of preload. Thermal cycling can cause 50 to 60% preload loss in real conditions. So it is an impact on safety and reliability. So reduced preload will give you reduced joint integrity, leading to component separation, breakdowns, and catastrophic failure. So reason to implement hard locks are anti-loosening locking effect all over the world, recognized by many countries, available in various materials and surface treatments tailored to the environment, reusable without reduction in performance, and full torque management and completely fasten even with zero axial force. And it's a maintenance-free, reduced total maintenance cost. So safety is power. So that's all from my side. And this was my small presentation, and I hope it was meaningful. Now, if we move through the entire value chain, at every stage there are going to be surface join and there are going to be vibrations. So this locking nut is the best solution everywhere. So now Hindalco has realized, and we are going to go ahead with Hindalco in coming days. And then that can give a good case study to apply to everywhere. So this was my end of the presentation, but I think my point was very important over here is in aluminum industry, safety cannot be neglected. And one of the way to contribute to the safety is keeping your surfaces together with a proper bolting and using hard lock nuts, keeping your bearings safe by using locking nuts. And this is a proven technology in Japan and nothing less than bullet trains. So this is the ultimate safety solution which hard lock nut is ready to offer. In India, we are our friends are representing them to help the customers to adapt to this technology. And this is a perfect solution, and it does not have any huge cost implication, but it offers a very high value of safety. Thank you very much for listening to me, and I'm open to the question and answer, and I hope my presentation was meaningful. Pradeep, you are on mute. Pradeep, you are on mute. Pradeep, you are on mute.
Okay. Yes, thank you, Kiran, for a nice presentation. And I think you have actually hit the right place. Safety is also important for very much important for aluminum industry, and I can tell umpteen things places where it can be used. While you were presenting and while you were showing the Shinkansen and other applications, steel industry and petrochemical, I was going through my days in Nalco, and I remember that we used to buy the lighting, lighting, illuminating equipments like lights and other things to have anti-vibration in pot rooms. So they're having some kind of anti-vibration pads. So I can tell you hundreds of applications in aluminum industry. Rightly, you have said that there is one rake which moves between alumina and smelter for carrying powdered calcined alumina. Those are the places where it can be used because they have a lot of vibration. And especially in smelter, I can tell you that you can use in the vibro-comforting unit in carbon area. In pot rooms, you can use for the where the girders are there for the pot tending machines, and then a lot of vibration is there. Then in cast house, and again in the cast house furnace tending assembly, and then you have got MTTs, vibrating screens and vibrating feeders and vibrating conveyors are plenty in the aluminum industry. So I think you have a very good future, and I mean you have a very good go in aluminum industry. And once you start with Hindalco, people will actually fall in place. Actually, these things will fall in place. So with this,
Yeah.
yeah.
Yes. In fact, in Hindalco, they will have a reliability conference or a reliability summit in coming days. So I am trying to invite Mr. Avdut and Mr. Torusan to this conference because most of the Hindalco people, they come together from different locations, and this reliability conference is from bauxite right up to the end of the cast house. So everybody will be there. So this will be a right opportunity to understand, and this is a safety value. This is not a pitch for the sale. It is a safety that we are offering as one of the solution.
Yes, it is mandatory. Now it should be mandatory actually. It's not that the cost would be a criterion, but still in Indian industry, people always look at the cost because as you see that people sometimes bypass the safety for the cost reasons. So that has to be also taken into account. But once I know that it's reusable, so it makes it very much applicable and very much interesting.
Yeah,
so,
reusable and maintenance free. Maintenance free. Once you lock it, it is like that.
Yeah, so it maintenance free and it can be easily fashioned. It's a very good fashioner basically. So in the meantime, let me invite other questions because there will be people who will be asking, rearing up to ask you questions. And with that, I open the discussion for questions. Thank you very much.
Thank you.
Any questions, please?
Mr. Kohler, Mr. Murthy, Mr. Kaji, you are most experienced people in the aluminum industry.
Good evening, sir. This is Murthy here. Thank you very much for a wonderful presentation. It has given us the lot of insights into the fascinating technology that has been adopted worldwide, particularly in these high-speed bullet trains. Now it gives a comfort also for everyone. Yes, we can safely travel into those trains. But here, sir, with the due apologies, I would like to correct a small statement you have made that in aluminum industry, the safety is taken a back burner. I don't think, sir. Maybe.
Oh, Uh,
You
that
know,
activity
because
hands-on actually.
I know just safety is for one's life. So every industry believes that yes, safety is the primemost and the first and last thing that should happen. I remember my experience in 1980s where I was working for cement plant. So it was a small place called Erraguntla in Kadapa district of Andhra Pradesh, where I had seen a very one safety slogan. Even today, I remember it and try to mention it wherever I get an opportunity. There are two slogans they agree on the safety day, they mention it. One year they mentioned safety celebrations on all are welcome except Mr. Accident. So the next year they have said the safety week begins every Monday. So that's why with all you apologists just to remove the myth. So please it will be taken because I agree. Your solution of these lock nets are improving the reliability, and rather they are removing an unsafe condition rather than a safety threat. Say like if we are using a conventional nets or some other mechanisms, wherein as you said the maintenance cost would be much higher. Yes, because I need to frequently say every 1 month or every 2 months, whatever be the frequency on the depending upon the usage of the equipment we may have to go and visit and retighten and take a downtime or whatever it is. Whereas when you are saying that go for these HardLock nuts, definitely it removes that necessity. Maybe when you have a normal long shutdowns, you can just check once for to see the condition. So definitely that advantage would definitely be there where you have this. And I would also like to say that cement plant is another potential area where you can look for because they have got reclaimers, they got stackers, they got ball mills, they have got vertical roller mills, where depending on the quality of the limestone, the vibrations are very, very high. So when the vibration goes beyond a limit, the mill automatically trips. It doesn't wait for somebody to go and check the cause of vibration. It trips for the sake of safety of the gearbox and bearings and all. So in that case, cement plant would definitely be a potential place where HardLock net can find its value addition and can improve the reliability of their equipment operations. And all. That's all I have to say. Thank you.
Thank you, Mr.
Yes,
Murthy.
Mr. Murthy, your observations are well noted, and your advice is absolutely perfect and highly appreciable, Mr. Murthy. And would like to be in touch with you, Mr. Murthy.
And sorry, it's not an advice. Just it's only like a comment. You can say that. See,
Yeah, absolutely.
You are really experienced, and you have seen the industry all over the world. So you had seen it many places. Yes, when we say, even I'll tell you, just when I joined the company, even if I get a small cut on my finger, it is treated as an investigation. So I was surprised. It is there a small cut on the finger. They're making inquiries, and as if I had done some big crime. But I started working and learning the culture of the industry. So things have been come and my thinking process started changing it. Yes, if you leave the small things and neglect a small thing, tomorrow that can become a serious thing. Because the attitude is the main thing rather than the severity of it. What has caused
yes,
by
Mr.
particular act.
Yeah, because a single accident will change everything. That's why.
It's just yes. Right, sir. Thank you very much.
Yes,
thank you.
Thank you, Mr. Murthy.
I would request Ms. Pallavi Deshmukh to please unmute and speak because she has been sending a lot of chats.
Oh, okay, Pallavi. Yeah, we are here to hear. We are here always to listen to you.
Audio is not clear, sir.
Audio what?
Audio is not clear.
Okay.
So I text my queries.
Okay, can you read these queries quickly?
What is the role of master alloy in the production of these nuts and bolts of aluminum alloys? Are you refiner or modifier or other master alloys?
No. These hardlock nuts are not done by, are not made by aluminum or any of the aluminum alloy. It is made out of stainless steels and high strength carbon steels. Am I right, Avdut?
So, Kiran sir, the standard materials that we provide in is low carbon steel, medium carbon steel, even in stainless steel. And for specialized customized orders, we do provide in special alloys or even special materials. Currently, one product that we're developing is Duralumin, an special alloy that is used in aircrafts. So it's very lightweight product, but it's also very expensive.
And I think also you have made have come out with a novel idea of making anti-corrosive locking nuts, bolt and knocking nuts.
I think what you're talking about is the one made with the carbon fiber, the plastic nuts. They are still under development. They are 80% developed, but they have not been tested yet. We have used it to display it in one of our exhibitions, and the strength is almost the same as the regular steel nuts, but it's still under development.
Yes.
Is Swagelock a competitor to HardLock?
Sorry, I didn't get that question. Can you repeat again?
Yes. Is Swagelock a competitor to HardLock?
Suez luck.
Yes, it's one of our competitors.
Okay. I know in North America they're very big. They have a very big presence. They're supposed to be. You pay a big premium for them. They're supposed to be very high quality. So I don't know if Swagelock was a competitor to HardLock or if they had a competing product or exactly how that worked.
So one of the strong points about HardLock is that it's a mechanical locking system, unlike other locking nuts, which are pre-bearing torque nuts. So if Kiran sir, can you please open the presentation?
Yeah, 1 second.
Yeah.
Give me a moment.
Can you please
Yeah,
open slide number 3?
Yeah, 1 second.
Yeah.
Slide number 3, right? Yes.
Yes.
This is the slide you want to speak about?
2 more slides. The
This one?
Next, one more. Yes, exactly. The previous one. One before. Yeah, this one. Yes. Importance of preload. Yes. Importance of preload. Not this one. The after that.
Swagelock uses a ferrule technology.
Before that, not after.
Locking mechanism of HardLock. This is the one you are talking about, Avdut?
Kiran, sir, the next slide of this, after this slide. Yes, importance of proper axial force.
Correct. Okay. So you're able to see this slide?
I see it.
So the main purpose of any locking nut is to keep two parts or two things to clamp together. And what
Two
the pre-bearing torque, yes, two surfaces, keeping the two surfaces together. So if there is a gap which is created between two surfaces, then the bolt is the one that takes the load. If there is no space, then the load is distributed evenly. So what happens in regular nuts is the preload is easily lost, and the main point of this regular nuts is they use preload as their mechanism. If the preload is lost, then the parts come off and accidents occur. But hard lock nut is a mechanical locking solution. So even in low preload or no preload at all, zero preload, there is possibility that there could be loosening or not loosening, but there could be gap between them, but the clamped products won't come out. That is one of the main strong point about hard lock nuts. So the preload control is possible with hard lock nuts. That is one of the most strongest points.
About 25 years ago, I was brought in by Schwazlock as a consultant to look at their business model. And their unique proposition was they use ferrules to clamp down when they would make a connection.
Mhm.
So you guys, to me, almost look like you guys are using shims. Like when you hang a door, the door jamb, there's a little gap in there, you put a little shim that takes up the extra space.
Yes. We use the wedge system. The hard lock nut is divided into two nuts, a lower nut and an upper nut. The lower nut is a convex nut and the upper nut is a concave nut. The lower nut has a protrusion over it. So one side is quite thick and the other side is thin. In comparison to that, the concave nut has an internal recess within it. So what we do recommend is when you tighten the lower nut, you tighten it according to the regular nut standards, which creates the initial preload that is necessary. That is the initial preload that keeps the parts clamped together.
Right.
Then we recommend that when you tighten the concave nut, that is the upper nut, you tighten it according to HardLock standard torquing values. When you do that, the internal recess of the concave nut pushes the wedge, the protrusion inside, and at the same time, the other side of the bolt resists it, creating an opposing force. So
As
the
opposed to using
opposing
a
force.
ferrule.
Yeah,
Okay.
the
Understand.
opposing force is what creates the locking effect. And even in heavy vibrations or low preload situations, hard lock nut stays strong.
Okay. So you use that technology more than you would use a ferrule. I know Schwazlock uses ferrules.
Yeah, we do not use any this kind of locking nuts system. It's for hard lock nut, like the hard lock families that Mr. Kiran sir had shown in the video. Hardlock nut has a rim, which is our flagship products. Apart from that, we have hardlock bearing nut, which is used on shafts in the injection molding machines or die casting machines, etc. Apart from that, we have HLS, which has threads on outside, which is used in die casting and die casting machines. And then we have space lock nut and other nuts as well, but these are mostly used in railways and within Japan. We don't have any application internationally.
I understand. Thank you.
Yes, any other questions? Mr. Khaji, would like to hear something from you.
I think it is a very ingenious product.
Mr. Khaji, can you switch on your camera? We would like to see you as well.
It is dark where I am at the moment. I am in US. It is not at this one. Okay,
understood.
1 minute. I will do it. I will do it.
Mr. Kaji, that is okay, no problem. Yes, very good. Nice to see you.
I apologize. But I find this product a fantastic product. It looks so simple and does such a wonderful job, especially from the angle of safety. safety. It is a really wonderful product. That is what I can say, not more than this. Thank you for your very fantastic presentation.
Thank you, Mr. Kaji, and look forward to meet you when you are in India.
Yes, sure. Yes.
Thank you, sir, for the kind words. I have a short story that I would like to share based on for HardLock. Is it okay?
Yes,
Yes,
please.
please go ahead, Avdut.
Yeah, so how HardLock came into existence is quite interesting. So, like Kiran sir had showed the presentation in the first slide, there was a picture of Mr. Katsuhiko Wakabayashi. So he was like our founding chairman, and in 1960s he had visited, not in 1960s, but in the late 50s, he had visited this American exhibition where an locking solution was displayed. It was kind of this big nut and had a spring in it. So by looking at it, he being an engineer himself, he thought that I would like to make something like this, which is more cheaper and it is more small, that it can be more used in Japanese industry. So by thinking, after some time, he came up with a product, and it is called as UNUT. So the structure was kind of simplified. So just like Mr. Kurt had explained before, a pre-bearing type nut, torquing type nut, which has metal flanges in it. So what you do is you torque it with a even higher with a higher force, which uh, grabs the bolt and keeps the locking effect. But what happened is after some time, customers kind of complained that the nut comes off, and there were some accidents, something like that. Although the company was doing very good, the sales were doing very good under this product, but he felt that we need to provide safety to customers and not just sell our products. So in the late 60s and early 70s, he visited this shrine in Osaka, in Japan, Sumiyoshi Taisha Shrine. And while looking at this Torii Gate, he came upon this idea. The idea is very simple. There is this Torii Gate in every shrine in Japan. There is a horizontal beam, there is a vertical beam, and there is two wedges that has been kept this structure, Torii Gate, standing tall for like 1,000 years in Japan. Even in earthquake, volcanic eruptions, this structure is like standing tall. So he thought to himself, like, this wedging system, if I could just incorporate it in the nut, it would be so good. And that's how he came up with the idea. Like, it took him 1 year to design it, but that's how hardlock nut came into existence. And ever since that, we have been applied we have used hardlock nut in a lot of applications, from rail industry to automobiles, but mainly rail industry, because rail industry has like safety is like very critical. As you saw in the last slide, in the UK in 2002, there was a Porter's rail accident. What happened is there were like few screws which were loose, and because of those loose screws, they just came out when the train was moving, and the train got derailed from the track, and it killed like 7 people, and like there were 70 injuries. Following this incident, UK and in London, I guess, they undertook an inspection as to what would be the best product or the best solution to this problem. And hardlock nut was chosen. And since 2003, Network Rail has adopted hardlock nut. And ever since then, there has been zero complaints about bolt loosening and anything like that. So
This
that
is Avdut. This is a best application for because tons and tons of alumina is transported from the refinery to the
Smelter.
to the smelter. So it's a big rail movement, and the rails are all have connections and the fish plates. So this can be easily replaced with the hard locks because you are applying this in the bullet trains, rail tracks. So this can be easily applied here to ensure that this derailment never happens.
Yes. Apart from that, like Mr. Lakshman, sorry if I misspell it, but like he had shared about ball mills and in steel industry applications,
Cement
like
industry.
cement industry, yes, in gearboxes and like ball. I don't recall the application, but in steel industry, like he had mentioned, like there are a lot of applications that could be done.
Yeah, it is basically, Avdut, in India, awareness program is required. And as compared to the other products, this is one of the ultimate solution. That's why it is used in bullet trains and the aircrafts. So why not
Yes.
use it in the process industry to make sure that the accidents at least are prevented by loosening effects. So they are prevented by hard locks. So well, Hindalco, we are very much in advanced stage of applying to their blowers and some of the gearboxes. And when they study and then when they feel convinced about this, they are going to apply everywhere in Hindalco plants. So that story
Yeah,
can be adopted by Nalco, by Vedanta, Balco, and Jindal and other big smelters, as well as standalone cast houses.
I would suggest that parallelly you can also approach Nalco and other places, because Nalco has their own rakes moving alumina from Damanjodi to Angul. So they will be interested particularly for the rails and of course for the pot rooms and the cast house everywhere, even the carbon
Yes.
area. So
Exactly.
instead of waiting for Hindalco's results, this hard knot bolt can be actually sponsored to Nalco also, because they will be interested, I'm sure.
Yeah. Okay. Yeah. Thank you, Pradeep. Thank you. Sure. Why not?
I think we were at the end of the session, and we can take one more question. If not, then I think we will call it a day.
Yeah. Or the questions can be written on the email, and we will
Yes,
answer
yes,
it
yes, yes,
back.
yes, yes.
Yes.
So,
Mr. Murthy, thank you, and Mr. Kolar, thank you. Mr. Kaji,
Thank you.
thank you very much.
Thank you.
thank you,
you,
Kiran, and for a nice
It
presentation.
was
And
a very good presentation, and the product is fantastic. Product is a fantastic, especially from the angle of safety. Very important. I mean, it is a
Yes.
very good product.
And very
Yes.
reliable. It is equivalent to the way we switch on the electricity in our house by switching on the switch. You get a robust way of electricity or light. It is simple technology, but a very unique mechanical locking systems.
very
Special
effective,
thanks.
very effective. So thank
Very
you,
effective, very effective.
thank you, Kiran, and I think everybody can communicate with you, because your mail will be there, mail ID. So I think we will also meeting in somewhere in IBAAS, some conference like that. And I would
Yeah.
request everybody to come into the IBAAS conference in Jharsuguda. That is on September 9 to 11. So I request all the participants to kindly join in their conference. And the circular is there on the website. Also, it can be sent to individuals.
Yes, sure.
So, thank you very much.
Thank you
And,
very much. Yes. Special thanks to Mr. Toru Teratani. Thank you very much. And Avdut from Japan. And
Thank you.
all other overseas guests. Thank you very much.
Thank you so much.
Thank you for leaving the call. Thank you so much.
Bye. Bye. Good day.
Good day.
Bye-bye.
Okay.